So let's go back to where we stopped in the last video. Now, my name is Muideen Waliu, popularly known as what Dr. Nefon. So the last video I posted was limiting and what an SS agent, and I was able to tell you how to indicate maybe the reagent is what is limiting or excess reagent. I introduced us to what's called the active modes, stoichiometry modes, and the calculated mode. That if you want to know that our limiting reagents, we have to know what's called the active mode. And I give you the formula for active mode to be what? To be stoichiometry mode, the calculated mode over stoichiometry mode. That is, the number of moles in the balanced chemical equation is called the stoichiometry mole. While the number of moles that you calculate by yourself is called calculated mole. Anytime you are dividing your calculated mole by the stoichiometry mole, so it gives us what's called the active mole. And I told that if you have two compounds and one of the compound has the least active mole, that particular compound or the element is our limiting reagent, and that's what we are going to use to calculate anything what the question is centered upon. So today, now look at this question so if 48 grams of oxygen was made to react with 5 grams of hydrogen, which of the reagents is in excess? If 48 grams of oxygen was made to react with 5 grams of hydrogen, which of the reagent is in excess? Look at this question, very, very simple, right? Now, let's go. Solution. Now, if 48 grams of oxygen was made, no, oxygen is diatomic element. The oxygen gas plus. Now, it reacts with 5 grams of hydrogen. Hydrogen is also a diatomic element. I have hydrogen gas like this. Now, to form H2O. Now, look at this. It is not balanced. The equation is not balanced. Now, before you can proceed, you have to balance the equation. And I told you that all balanced chemical equation obeys law of conservation of mass. Again, all balanced chemical equation obey law of conservation of mass. So that means we cannot use this like this. We have to balance it before we can proceed. Now, we have 2 moles of oxygen here. We have 1 mole here. I'm going to put 2 so that oxygen can be balanced. Now, it has actually affected the hydrogen here. 2 times 2 is what? Is 4. But we have 2 here. That means I have to put 2 so that it can also balance for hydrogen. Just put your gas here. Your gas. Now it is balanced like this, you can proceed. Now, in 48 grams of oxygen, you write mass of oxygen is 48 grams. Was made to react with 5 grams of hydrogen. Mass of hydrogen is 5 grams. Now, which of the reagent is in excess? Now, you are going to calculate the number of moles for each of the elements, which are oxygen and hydrogen. Now, number of mole of oxygen gas equal to mass of the oxygen over molar mass of the oxygen. Now, the mass of oxygen given to us is 48. That is 48 divided by the molar mass of oxygen is what? Is 2 times 16. 2 times 16, no? We are given oxygen to be 16. But oxygen is a diatomic element. So 2 times 16. That means we have what? 48 over 32. Now, if I place 48 over 32, it's going to give me now 1.5 mole. 1.5 mole. 1.5 mole of oxygen. But class, the number of mole you calculate by yourself is called calculated mole. This is the calculated mole of what? Of oxygen. Now, to find the active mole of oxygen, active mole of oxygen gas is now equal to calculated mole over stoichiometry mole. This is calculated mole that we calculate by ourselves, 1.5. 1.5 divided by the stoichiometric mole of oxygen here is 1. The coefficient of oxygen here is what? Is the stoichiometric mole of oxygen, which is what? Which is 1. Now 1.5 divided by 1 will give you what? 1.5 mole. That means active mole of oxygen is what? Is 1.5 mole. Now let's take that of what? That of hydrogen too. Now look at the hydrogen. The mass of hydrogen given to us is what? Is 5 grams. That means number of moles of hydrogen gas equal to mass of hydrogen 5 over molar mass of hydrogen. Now we are given the mass number of hydrogen to be 1, but hydrogen is always a diatomic element. That's what? 1 times 2, which give you what? 5 over 2, which is equal to 2.5 mole. Now what I calculate here is what is called the calculated mole for what? For hydrogen gas. I have to convert this to what? To active mole. That means active mole of hydrogen gas equal to the calculated mole over stoichiometric mole. Now calculated mole for what? For hydrogen gas here is what? Is 2.5. But if you look at the balanced chemical equation here, we have 2 moles of hydrogen gas. This 2 is called the stoichiometric mole of hydrogen. Now I'm going to divide it by 2. I get now. So it will now give us what? 1.25 mole. Is that okay? Now 1.25 mole. Very correct. Now that class, don't forget, I told you the last class, or in the last video, that if you calculate the active mole for 2 elements or 2 compounds, the one with the smallest active mole is our limiting reagent, while the one with the what? With the highest active mole is our excess reagent. Definitely. Now if you look at it now, hydrogen gas is what? Is limiting. Is limiting reagent. Why what? Why oxygen gas is excess reagent. That's it. So very simple. Because I told you that if you want to know your limiting reagents, the one with the smallest active mole, compared to this one, 1.5 mole of oxygen and 1.25 mole of hydrogen, which one is the smallest? 1.25. Which one is the highest? 1.5. That means oxygen is what? Is in excess. Why what? Why hydrogen is what? Is what? Is limiting. Now, Jam can now ask you a question that by how much is the what? Is the oxygen excess? By how much is the what? Is the oxygen gas excess? Now, if I want to know oxygen is in excess by, now you will now go and remove the smaller one, that is the smaller active mole from the bigger active mole, by 1.5 minus 1.25. If I want to know by how much is oxygen gas excess, I'm going to remove the one, the smaller one from the bigger one. So it will now give me what? 1.5 minus 1.25. So to give me what? Give me 0.25 moles. That means what? Oxygen gas is in excess by 0.25 moles. So I hope you understand it very well. Now again, if 48 grams of oxygen was made to react with 5 grams of hydrogen, which of the reagent is in excess? I told you the first thing is what? Write a balanced chemical equation. Oxygen gas plus hydrogen gas to give what? To give 2 moles of water. 2 molecules of water. Now you can see 2 times 2, 4. 2 times 2, 4. 2 times 1 here, up 2. And 2 here, that's balance. Now, we are given the mass of oxygen to be 48 grams. We are given the mass of hydrogen to be 5 grams. Now, the first thing you have to do is what? Calculate their number of moles. And the number of moles you calculate is called calculated moles. Now, for oxygen now, it will be what? 48 divided by the what? Divided by the molar mass of what? Of oxygen gas, which is what? 2 times 16, 32. 48 divided by 32 will give me what? 1.5 mole of oxygen. This is what? Calculated mole for oxygen. Now, you will now convert it to what? To the active mole. That is what? Active mole of oxygen is equal to the calculated mole, which is 1.5, divided by what? The stoichiometry mole of oxygen here, which is 1. So which will give me what? 1.5 moles. Now, for hydrogen too, we are given the mass of hydrogen to be 5 grams. That means what? Number of mole of hydrogen gas equal to what? Is equal to mass over molar mass. 5 divided by, now the mass number of hydrogen is 1, but hydrogen is a diatomic element. So 1 times 2. 5 over 2 is what? Is 2.5 mole. This is the calculated mole for hydrogen. You cannot use it to determine either is excess or limiting until you convert it to the active mole. Now, active mole of hydrogen gas equal to calculated mole, which is 2.5 over stoichiometry mole. You can see the coefficient of hydrogen here is 2. Now divided by 2. Now to give me what? 1.25. That means hydrogen gas is limiting. Why? Because it had what? It had what? The smallest active mole. While oxygen is in excess. Why? Because it had what? The highest what? Active mole. Now, if they now ask you that by how much is oxygen gas excess, that means you are going to remove the what? The smaller one from the bigger one. Equal to what? 1.5 minus 1.25 equal to 0.25 moles. So that's it.